Yeah. Can you share your screen, Yifeng?
Well, I can.
Can you go full screen?
Uh,
Okay, so let's start. It's our great pleasure to have a special talk in our Mitake seminar today with Professor Yifeng Yu from UC Irvine. He's gonna give a talk, very interesting one on evaluating AI grading on real-world handwritten college mathematics. Please, Yifeng.
Okay, so first of all, I will thank Han for this invitation because this is the first time I give a non-PD talk in a regular seminar, a serious seminar. I talked about this before in some conference, like for high school students, but this is the first time ever I did this in a regular seminar. Okay, yes, thanks everyone for coming. So I try to make this as informal and relaxed. So if you have any question, you can feel free to ask. This does not involve any PD techniques, right? Compared with the PD techniques, those techniques are not that advanced. So I think it would be more easy to interact. Anyway, so feel free to interrupt me. Okay, so when we see the word, right, AI grading, so I think it's easy to understand. It just means we use AI tools to grade uh, student works in mathematics. So here we focus on is handwritten works, so which means you see very messy things. Now, so AI, usually when we say AI, it means large language model. We use a typical example is GPT or ChatGPT. If you use the web version called ChatGPT, right? All right. Now, here, so I first thing, so this is the central message, which is the central difficulty. If we, from the point of view of theory in LLM, is there's no ground to choose. So if you do AI grading, what you face is a very realistic, mean very noisy situation. Why? Because what we get is handwritten student solutions. It could be like student could scribble and hard to recognize and the different ways to approach the problems, right? So typically, I think if you have heard about talks about LLM things, usually people say, okay, we introduce an algorithm and we compare with the benchmark and the accuracy has been improved by 2% and 3%, right? So this is how people used to justify that their model, their approach is good. But if you have such kind of task, large language AI grading, the first thing we have to ask, we need to think about is, let's say you have designed an algorithm for AI grading, then how do you know it's good, right? There's no benchmark, there's no absolute want to choose to compare with, and that's the main difficulty. And also in reality, that is also many tasks that face this kind of challenge. Now, of course, our goal is not just to provide scores, but also to provide feedback. Means we need to tell students where did wrong, why this is wrong, right? Where you made the mistake, because this will be more useful for us to learn instead of just getting a score, right? Okay, so this is the main thing I want to. You will see I repeat again and again is for AI grading from the point of view of theory and approaches. The main challenge is there's no ground to choose. Okay, now let me quickly tell you the outline of my talk. So first of all, I'll give you some background and motivation, like why we introduced this grading, and then I'll briefly show you the workflow, how the pipeline is designed. It's basically two parts. The first part is OCR. So OCR means, okay, we get the handwritten solution, right? The machine has to recognize it, convert it into a latex, right? So we use latex. Then this is from the technical point of view, this is one of the central tech challenges in machine learning, right? To recognize things, to read picture and read um, those words and especially mathematical writings. And then after you get a latex output, and then you send this to large language model to evaluate, get evaluation. So here we use, of course, you have to choose, right? What kind of tools you use for OCR. Okay, so here I use OCR just means read the algorithm, the tool to read the handwriting things. So you have to decide what tool you want to use, right? So there are many choices. Also, we know there are different LLMs, right? We have GPT, we have Gemini, and those kind of DeepSeek, right? Okay, so how do you decide which one you want to use? This is unlike from mathematical things that we prove. We say, okay, we prove this is correct. There's no way we can prove it. We have to do experiments to check. Now, based on our experiments for OCR part and evaluation part, we use ChatGPT 4.1 mini. I'm not claiming this has to be the best one, but if you combine the accuracy and cost, and this is so far, I think it's a good candidate. According to our experience, it's a good candidate for this task. And then we come to, I'm going to talk about the validation. The key question is, how do you tell, right? Okay, so you introduce the algorithm, and then you did experiments. How you tell people why your algorithm is good, right? As I said, there's no ground truth. You cannot compare with a benchmark, say, oh, we have improved the 20%. There's no such things as improvement of what percent. So what do we do? So we introduce three ways to verify it. The first one is compare with TA scores, right? Okay, you can have scores from this AI grading, and then you have scores given by TA, and you compare them. Then you might be asking, well, but TA scores are not ground truth, right? TA could be very subjective. True, that's correct. But the thing is, if you want to, let's say, what can you compare with? If you want to deploy your model, if you want to convince people this is useful, the first thing people will say, how about compare with the TA scores, right? So this is kind of, we call it operational benchmark. It's not the real benchmark, but it's operational benchmark. And then we ask, the second thing we did is we send those feedback and evaluation results back to students. And then we did a survey. We asked them for feedback. What do you think? What do you think is accurate? Do you prefer it's TA or it's AI? So this is to from their perspective. They're big users, right? From user perspective to see their acceptance, how they view the AI to grade their work. And but you see, for both TA and the students, there are bias on it. You think of students. If students got a score from AI, if the score is lower than the TA scores, then usually students will not say, "Oh, I like AI score because it's more strict, it's more accurate." Students might come more likely to complain AI is harsher, right? So then we have the but TA also it's under a lot of pressure and to do things. So the last way is we recruit independent reviewers, not a student, not TA, to look at the outcome of our AI grading. So to provide their evaluation, how accurate the feedback and the scores are. Okay, and then I will talk about technical details, some technical details. So this is the main technical details from which is more like engineering part. That is because we are used large language model. I think it's wait, why did I raise my hand? Okay, all right. Anyway, so the thing is, if you have used, yeah, you have two ways to use large language model, right? One use the web version, like the ChatGPT. So another one is through API. If you want to connect from your coding one platform to another, right? Use API. The thing is, you have to write, especially for API ones, you have to write for the web version similarly. You have to write prompts, right? You have to tell the large language model what you want. And then we know large language models are sensitive to prompts. And then you have to write accurately. And then from the experiments, you have to see how you should write to get what you want. So this is called prompt engineering. And we spend a lot of time on that part to write things to work for us. Okay. And then the final part I talk about limitation. And there's several things that need to be improved and need to be uh, to be done in the future. But the most important thing is to find robust algorithm. Say, okay, automatic algorithm to say when this paper, this work need to send to human reviewers. Need to send human reviewers. That's very important if you want to deploy a system, right? You cannot. So this is something have to be a robust principle has to be introduced, and this itself is active topic in machine learning. You think of like medical diagnosis, right? The AI read a lot of things, and then you have to decide some point is which one should be sent to an expert, right? To a radiologist to take a second look. So here is similar. Okay. So finally, I will mention that students and people that who have contributed to this project. Okay. All right. Yeah. Anyway, if you have any questions, so I try to make this like storytelling. If you have any questions, feel free to interrupt me.
Just a comment. I mean, no, 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 nothing but your talk. It's just
Yeah.
that, it's AI recognizing you raising your hand.
Yes, very likely, very likely. So think I'm raising hand, but it feels to recognize I'm the speaker. I'm not. Okay. Good. All right. Okay, so as I said, let me quickly. So the goal is want to build the AI grid system, provide both score and accurate feedback for large enrollment. So here, a large enrollment means there are hundreds of students. Sometimes could be more than 1,000 students. And our original focus is on calculus. That's our primary goal. But I think it could be extended to other low division, computational based. Proof based is another story, but computational based, I think, is pretty much similar. Now, the value, as I said, is to provide not only score but a feedback. You think of TA, right? They have their own research assignment, other things to do, their own coursework, their research project to do, and if they need to grade like hundreds of problems, so it's not very reasonable to expect that they could spend a lot of time right read those things carefully, and usually they will not write personalized detailed feedback. Typically, just fixed rubrics on the grade scope. Okay. All right. And then so far, so our status is we have tested our algorithm on thousands, like more than 2,000 quizzes on a single variable calculus. At UCI, this we label it, the course names are 2A and 2B. So it's single variable calculus. And the results are quite nice. You will see later. Now, the reason you say, okay, why we only focus on quizzes, why we don't do homework? Because given today, if you for college maths, right, ChatGPT could solve all the homework problems. So there really no need. I don't, from my personal view, there's no really no need to grade homework problems. And for exams, they are too risky. We don't put too much pressure on students. So we choose something which is has some. It's not like for has some like it's just mainly you can think of quiz as a test, just to have like less problems, right? So that's a good it's a good place to test. Now, of course, we are definitely not the first group to use AI, to think of AI. You think of like after in introduction of ChatGPT, especially ChatGPT 4.0, I mean, it's very natural, right? People try to think of applications of AI in many fields, right? And education definitely is one of the most important ones, right? Education, medical science, and in other things. And seems it's very interesting if you search like AI grading, you see quite a few literatures that emerged from 2024, especially some groups in Europe, like ZTH, ETH, yeah, Zurich. So they have some studies. But if you look at the main difference between theirs and ours is they mainly focus on scores, trying to compare the score with TAs. But our focus is not only score accuracy, but they're also on the feedback. And they typically is on small scales. Okay. All right. Okay. All right. Uh, okay. So here's I just explained a little bit why I choose single variable calculus because it's relatively simple and it's required for all STEM majors. And at least at UCI, the enrollment number of students is very large. since 2004, I have been the calcs coordinator for this 2 and 2B, and this is the first time I have witnessed the workload is so huge for this for the two courses. And at that time, I think ChatGPT 4.0 just emerged. So I just asked myself, wait, come on. I mean, given we have like those this development of AI tools, why do we still need a human to grade those low division computation-based courses? So that's how these things started. So the original goal is to do for Math 2 and 2B, and it actually turns out much harder than I expected. First, I thought, well, you have GPTs, very powerful, you can do it. But later on, we discovered there are a lot of hidden difficulty and technicals that we need to overcome. Okay, so uh, any questions so far? All right, good. Okay, so here is a sample. So this is from multi-variable, not multi-variable, it's from single variable calculus. It's infinite series. So infinite series is considered one of the most challenging topics in single variable calculus, because if you look at what a student did, all right, so they usually get confused about adding things up and da, da. So this is one sample. So you see, this is the answer sheet we provide for AI grading. And we separate into three parts. This is the solution part, and this is the answer part. So this is for segmentation. So the algorithm is going to do is, if I have enough time, I will show you later. I mean, I'll show at the end of the talk how our algorithm works. Okay, so a vivid demonstration. All right, so it's going to crop, do segmentation, uh, um, divide this in according to those boxes, and then send each one to GPT 4.1 mini, this OCR to convert into latex, and then to do evaluation. Okay. So you see, so this actually is not too bad. This student still, I mean, you might think it's a bit messy. For our human, if you want to read, right, have to read each step, you might feel this is kind of not very easy. But there are more messy student work than this one. Okay, all right. Okay, so here is the workflow. So we have like say hundreds of quizzes, and do it separate into each one. It has a solution part and the answer part, and then you separate into these two parts, do segmentation, and you send the OCR to read. You have latex output, and then send those things to again to these GPT, and we have way to design rubrics and the prompts you'll see later, and to provide feedback, and then we email those feedback, the result back to students. So this is how it works. Okay, all right. All right, so this is just repeat what I said. So first one is the OCR. You do handwriting to latex, and then we design rubrics and the prompts to evaluate. Uh, Okay, so here for the OCR part, I think 4.1 meaning is overall in general it's good. It's not perfect, but I think in general it's good enough. For the evaluation part, we mainly use 4.0 mini. That's because single variable calculus is not very complicated. Usually the computation it does not involve like a lot of things, right? But if you have some calculation, some problems, let's say it's more challenging than the others, it has, especially if there's more algebra involved, then we can replace that part with stronger models. For example, 3.0 mini, that will be slightly more accurate. But of course, the price you have to pay it is more expensive. It actually is much more expensive than 4.1 mini. All right, so we basically have to balance between the cost and the efficiency. Okay. Is there any question? Okay, right. Okay, all right. Okay, now we are going to, the first part I'm going to talk about is how we design rubrics. You think of the scenario, right? So what is the problem we face? The student might have a different way to approach a problem. Even some ways are not very accurate, but there's some nice idea there, right? I mean, if you look at student solutions, believe me, you will find the solutions you never expect. Although we might think that there are some very standard, right? So, okay, that has to go that way, but the student will have very interesting perspective to think of that. And they will make a lot of different type of mistake. Now, if you just use a fixed rubric, you say, okay, I write down rubric. Or if we did this, you get 1 point, get this, get a point, right? It will never always fit into your rubric. Then you have to decide, okay, how should I deal with it, right? As a human, I think we all have graded civil exams, right? At some point, we always have to adjust in our mind. Okay, this is not the exact match the rubric. So how should I give it? Well, I should give more points because this is a nice idea. Well, I should deduce less because this is not as bad as the other ones, right? So as a human, we can adjust. There are some unwritten rules in our mind. Then the question is, how could you mimic the same thing for ChatGPT, for GGPT, right? For large language model. And I don't know about individual, but overall impression is from TS, I think they tend to be more generous. I think for myself, I also, when I grading student works, when I see something which is nice, something which is related to the correct solution, I'll give more partial credits just as encouragement. Okay, all right. So that's the from my observation. Maybe that in different universities they have different culture, but from my observation, is tend to be more generous in giving partial credits. So the thing is, okay, how should we design a rubric in this way? Okay. All right. So the method, the approach we used is this. We say, okay, we give different rubrics, multiple rubrics. One, the some of them is just let's say the problem a different way to solve it, right? Typical ways to solve it, and each way will be rubric. But on top of that, we are going to put we call the flexible rubric, flex rubric. So typical scenario is there are two rubrics if the problem is not too complicated, like single variable calculus. One is fixed rubric, just a very detailed point distribution. Right? If you do this, you get how many points. Da, da, da. But flexible means just give some loose uh, criterion, more rooms for the ChatGPT to assign scores. And then you run each rubric. Finally, you choose each rubric will give you a score, right? And which what we use is use the maximum rule. We use the one that gives the maximum score, and choose that as the output, and choose that to the corresponding feedback as we're going to send it back to students. Okay.
Can you say a bit more about the flexible rubric? Is it sort of you go either sort of maximum score and then you deduct some points, or you know like or what you know?
Okay. Let me show you. Let me show you the example.
Thanks.
All right. Look at this. So here's a problem, right? Here's the problem is find the sum of the series. Okay. And then this is the flexible rubric. It's okay if the reason, you see, it's not a very detailed description. It's just some general idea. Say, okay, the reason is coherent, find answer simply using the direct method, and then you give 3 points. And then partial credits, if there's some correct components, there's something that's right, and then you give partial credits. Now here you can you can make a little bit more detail. Say, okay, if you did this, then you give between like 1 or 2 points, between 1 to 2 points. You give some flexibility to it, and then you say, okay, just tell them something. Say, okay, if still the re-indexing and these kind of things, treat them as correct. So this is try to the idea of they try to accommodate the unexpected like steps to use and different perspectives and different mistakes they made. So this is the one example of flexible rubric.
Yeah, I have another question here. So hypothetically, let's say that I do all this thing wrong, indexing everything wrong, but then suddenly I get the correct answer, then what would this flexible rubric handle it, you know?
Okay, now so here that's a very good question. So if it's a flexible rubric, I think it might assign, say, let's 3 points. It might assign like 1 or 0.5 point for say, okay, get a correct answer. But it will say the reasoning and the logic is not correct
Mm.
and reduce per point. Okay, so if we go to this is detailed. It's very detailed. Okay, you write with step. You say state that it's geometric, blah blah, and you get 1 point, and compute that you get another 1 point, and then you get 1 point. And this is the detail rubric. Now, so let's say for this example, right? We have two rubrics. We choose the one that gives the larger score. Now, it could happen both ways. At first, you might think the flexible one might give you, this is what I originally thought. I think typically the flexible one should give a high score, but actually that's not the case. Then we say, why the flexible one, why it could happen, the flexible one doesn't give the highest score. That's because if you tell the flexible one it has to be logic, sound, it could still could write something which is not very coherent, but at some point they write a nice, a good step. Then the flexible algorithm will think, okay, you have a correct step, but your overall argument is not correct. Therefore, I'm going to ignore that one you wrote. But if you look at the fixed rubric, then fixed rubric, of course, as long as you student writes down r equal to a two-third, it will give a score, right? But of course, the other way is more easy to understand. If students, it does not go this way, right? They use another approach, another perspective, then this fixed rubric might not give enough points, but the flexible one will. Okay, okay. Now, heuristically, so this is when we introduce this Maxwell rule, introduce the Maxwell rule. Um, heuristically we think this should be the right way to think because it will be more generous. It try to capture like all kind of scenarios. And but the thing is, this is just heuristic, right? How you prove to people, right? Say if you want to write on a paper instead of just promoting, right? If you want to write a paper, you have to how you convince people, right? So by the way, this Maxwell was first actually proposed by an undergrad student. It was very interesting. So I like in 2024, so I was giving a talk at the department about AI grading, and many undergrad students came, and there was a student at the audience, and he told us he's a very smart student. He said he himself was testing AI grading, and he said he used different rubrics and then takes the max. But here, what we did is we said we need to add a flexible rubric just to capture other things. But choose the maximum rule. If you have different rubrics, choose the max. Actually, was first proposed by that undergrad student. This is quite nice. Okay, all right. Anyway, so let's back to. But then, how you convince people this is a good way to go? Then you have to. What you should do? You have to compare with TA scores. Although you have to. Oh, I don't. TA scores is not the ground truth, but that's the only practical way to convince people. Okay, to at least that for to some extent it's good. All right, so that's what we did. So we test this on hundreds of we choose like say here we have 2A, 2B, and then we choose two most challenging quizzes from the two courses, and then we compare, right? So here is the graph. So here we first of all, so okay, we run the algorithm and we record the score from each individual rubric and from the max one. And then, okay, so here you see we have three bars, right? So the blue bar means the score just from the flexible rubric. And the orange one is the one that from the fixed rubric. And then the green one is from the max rubric, max rule, just choose the maximum one. And then we compare with TA scores and calculate the average, the error. And then you find thing, okay, you will find maximum rule is always achieve the lowest one. You see? So this is a good way. I mean, it's a valid way to tell people. You see, okay, at least if we use TA scores as a reference, then the maximum rule is uh, is a suitable way to go. But of course, people might ask, why use maximum rule? Why don't you try like a different interpolation, right? Maybe you choose the maximum, you choose the flexible rule as 1/3, use the fixed rule as 2/3. You use linear combination or even use nonlinear combination. Maybe there are better ways. Yeah, I cannot claim maximum rule must be the best one. If you try to, that's an interesting question to see which one to be the best. But to be best, again, you have to compare with what? You have to compare with TAs. But at least for now, we think maximum rule is a workable one. So it's a reasonable one given this comparison.
You have
Just a curiosity.
Yeah.
For the ones that did the best, like BQ5 P2 and BQ6 P2, what kind of questions were those compared to like BQ6 P1?
Oh, those are infinite series.
Oh, all those questions are infinite series one?
No, B is infinite series. A is integrations.
Okay, so
Yeah. Because for here at UCI, so single variable calculus has two courses, A and B. So A, I think, covers the limit and integration with derivative things. Yeah, I can't remember correctly, but the limit and derivative, and the other one is integration and infinite series. So I choose for each course, I choose the most difficult part to complete.
mm,
Yeah, so can I ask, like what you said, yeah, the deviation, some problems, like what Adrian mentioned, it's quite small, right? 0.5. Some problems, the deviation is quite big, right? One
Mhm.
out of four or one out of, I mean, is it acceptable, the deviation?
Okay, so deviation 1 point depends on. I think it's as long as that's a good question. So I think it's as long as within one or near one. So we think that's acceptable. Let's think of this. Suppose a problem, right? The total score for that question is five, right? It's five. And then let's say you are given partial credits. So I think it's kind of common. Let's say one TA give 3 points, another TA give 4 points. So I think 1 point will be reasonable.
Right. So I mean, your deviation is out of five, right? So for example, 0.5 out of five is very good, right?
Yeah, sometimes as I5, sometimes it could be 3 or 4.
Yeah. Okay. Yeah. Thank you.
Right. Yeah, very good question. Okay. All right. All right. Okay, so now let's go to the part, right? We have to evaluate, right? The overall, right? You have algorithm, how it works, right? Okay, so as I said, the main thing is it's there's no ground truth, right? So it has no ground truth because of two things, right? Now there are different reasons, but two main sources. One is the partial credits is very subjective. Which you can try on different TAs, right? Even sometimes will be more general. Sometimes you could even have like a difference of two points. And then also, let's say go to feedback. Even the feedback, you try to write, okay, where did you wrong? The feedback, there's no way to define what do you mean it's a good feedback, right? The feedback sometimes might not be very accurate. Sometimes it fail to point out this is wrong. Sometimes it maybe should suggest a better way to solve the problem. Well, there's a kind of this. Okay, so then the question is, how should we evaluate, right? Given such kind of uncertainty, how should we evaluate? And as I mentioned at the beginning, so we did is we can think of three ways. One is again compare with TA scores, right? So that's operational benchmark. And then from user point of view, seek students' feedback, how they think of their accuracy or how good this AI algorithm is. And the last part is the most time-consuming one. So we recruit uh, more than 20 independent reviewers. They include graduate students, undergraduate students, and high school students. In high school students, they have learned AP calculus, and if they are strong, then they are well qualified to evaluate. Because single variable calculus is basically, if it's computational based, is basically AP calculus, AB, or AB and BC together. All right, so that's what we did. Now let's look at one by one. Okay, so the first is we compare with TA scores. As I said, TA score is not the ground truth, but it's a good reference. And if we want to deploy really deploy this, then you have to tell people how close is it to TA score. Okay. All right. Okay. So here we compared with like near 4,000 responses. And then you can see most of them it's almost the same or very close to each other. So great majority is within plus of 1 point. And the main difference is negative 0.5. So which means overall TA is harsher than no, sorry, AI is harsher than TAs. But if you look at the picture, this is kind of understandable, right? Because from TA point of view, I understand they as human they want to be sometimes want to be more generous to students. But AI will follow what you not not exactly follow, but will pretty much will in generally follow what it needs to do. Okay, but if you look at this comparison, you say, okay, yeah, this is nice. Okay, and then this is the survey result we did with Math 2A, so one course. It has more than 300 students. Uh, so this is the response we get. There are two sections. Very interestingly, if you look at it, you find the percent is very close. So this is quite amazing. So these are two sections, but the response, but if you look at each category, how they think of AI is accurate or not, is the feedback clear? Do they prefer TA or they prefer AI, or whether they want to open to AI in the future? Like regardless what is their current preference, uh, do you open to AI in the future? You see the numbers are very close to each other. And here we can see is one thing we notice is still they prefer TA. So this is understandable, right? Especially if you go to those high-stake exams. If you have a human to talk to, they will psychologically, they might feel more comfortable with it. So this is from the user perspective. Okay. All right. Okay, so here is what we got. The comparison result we got from independent reviewers. And then you see, we asked them to review several things. Number one is the OCR quality. You see, OCR is a key part because if OCR didn't read correctly, then the evaluation will not be reliable, right? Okay, so this is good. The OCR overall quality is pretty good. 87%, near 90% is considered acceptable. Acceptable means either 100% accurate, or there's some small typos, but it's not going to affect how you evaluate the problem. And for score agreement, we also ask reviewers to give their own scores. And then again, majority of them, it's quite pretty much the same with the AI score. And another important thing is, so that's I think, yeah. So the look at the rubric, right? How it matches the rubric and the feedback accuracy. You see, around 80% think is fully correct. Around 10% is accurate. So again, it's near 90% think is either accurate or it's acceptable. So if you combine from those things, from the AI score, from these comparisons, you think, okay, the result actually is quite good. All right.
Yifeng.
Any question?
Yes. So it seems that you guys are giving maybe the first or the one of the first benchmark here that the acceptable result within plus minus one is 90% from both TAs and reviewers' perspectives. Is it kind of the first
Right, because
benchmark?
yeah, well, we don't have to say this benchmark, but this is kind of a criteria we use because you see, because when we grade the exams, right, we don't do like a zero point 0.1 thing, we do 0.5 thing, right? So if you have a difference, at least the difference is 0.5. So you
Right.
have more, it should be a 1. So 1 will be kind of common
Right.
difference. Yeah.
Yeah, my point is that if the benchmark of plus minus one is kind of greater than 90%, that is a very good benchmark actually.
Right, right. Like from this point of view, yes.
Yeah.
Yeah. Okay. All right. And that the thing about independent reviewers, because we ask each of them to review a certain amount of works, and I think they devote a lot of time on it. So I would say that their feedback will be considered to be quite accurate and serious. Okay. All right. Okay.
Actually,
Now,
Ethan, can I
yeah.
ask, so what is the distribution of like correct solutions, like the student solutions? Because in my opinion, like it's very easy to grade like correct solution, full score, right? But the problematic are the ones that are like in the middle. That part is correct, part is incorrect. So then the distribution will be probably like less predictable. So if
Right.
your questions are very simple and most students are getting full score, then maybe it's not so surprising that you have like 90% agreement, right?
Right. Okay. Let's put this. So Norbert asked a very nice question. So the question basically, let's say if all students, let's say you have 100 students, right? If 90 of them get full score, then you only need to compare 10. Even for the remaining 10, if they did all wrong, then still you get a nice match. So here's the point of this. Because even for full score, this is not like we only check the answer. You have to check the solution part. So
Hmm.
even the student did correct does not necessarily mean the AI will give the full score because it has the OCR problem and AI has to understand whether the student did correct. So it's not like a multiple choice or fill in blank. So still it has
Hmm.
to evaluate how it did it. Yeah.
Yeah, maybe,
Okay. Yeah.
yeah, maybe what Norbert's point and my point is perhaps if you have I mean, like, of course, lots of information already, but if your matrix is broken down more in details, that would be actually more, like the problematic ones are on which kind of, population.
Right. Right. So if we can definitely do that. So this is like later on when I'm going to if later on we are going to set up database, then we'll do more detailed. But if you look at about the full score, it's not like as majority you think it's the full score. Even the problems we think is very simple. It's not that the case. Yeah.
Mm.
Okay. All right. But very good point. Yes. All right. Okay, so now let's go to and you will see from the evaluation part. Okay, so now let's see this. Okay, so because this is the LLM, you have to write prompts very sensitive. So the thing is, we have to nicely write it to make it work. Now, at some point we're very confused because we see at the beginning of the test we saw something which is very puzzling. At first we didn't understand. The thing is we tried one thing on the web version we call ChatGPT, and then we tried the same thing through API. Because we have a large version, you have to go with API. We find even with the exactly rubric, exactly input, the output is very different. No, not very different, but the output sometimes the web version is more accurate, more thorough. And first of all, we didn't understand, but even now it's not for sure what is the reason. But we think it just could be, just speculation, might not be true. But speculation is the web version, it might have hidden prompts. We don't see it, and this is not like disclosed. So that, but anyway, this tells us when we use API, we have to write down clearly what we want the API, what we want the ChatGPT, what we want the LM to do. Okay, so oops, okay, I need to. Okay, let me show you. So this is our OCR part. We want to read it. So OCR is again is GPT. Right. So we first state the problem. We need to tell the GPT what the problem is before it reads. And then we add two instructions. One is we ask them to identify any text in the image and convert to latex, and then do not correct any math or logical error types. Okay, so we didn't put this together first. We followed this is because when we do experiments, we find failure cases, and then we go back to correct it. So the first one is to rule out hallucination. It could happen if a student wrote the value at all or nothing on the answer sheet. If you don't write this prompt, GPT might produce something completely irrelevant or just give you the full correct answer. That happened. And the second one is if you don't say that, it will do auto correction. I will show you an example, a very rapid example. Okay, look at it here. Okay, so first I use the example to show that the power of this. Now, the GPT based is reasoning based. It's unlike like usually we use CNN and those kind of things, right? Just do match things. It doesn't. It will utilize the context and then try to understand. If it cannot decide, cannot determine what it is, it will use the context to see what is. Now let's look at this one. When we see this one as a human, we immediately realize this should be there should be a parenthesis, right? To the end because it means 2 to the n. But if without this thinking, it's very easy to think this is 2 to the n over 3, right? So this is one thing. Another one, look at here. If you don't look at the context, we forget about context, what do you think this will be? Well, I think this will probably just like 1 2/3, right? I don't know what it is. So even as a human, without context, we cannot read it, right? Okay, now let me show you the output from ChatGPT from this GPT 4.1. It's perfect, and the GPT 4.1 it added the parentheses to it, and it correctly recognize this. So if you compare it, everything is good. So this is not a single case because we checked like thousands of copies. It's overall it's pretty amazing. Okay, but
So
yeah.
here your prompt is that do not correct the right thing, but it still gives you this, which is kind of perfect.
Right.
Okay.
Good. Yeah. Now, let me show you an example of autocorrection. If we don't add that, okay, look at this one. The student literally load to 3.2 equals 6. That's exactly the student load. Maybe he did in rush, but whatever, he load this. And then if we don't add the prompt, do not correct math errors, you run 3 times. The first 2 times are okay. It just uh, convert what is load. But the third time, it corrected. It correct 3.245 because the LM might think, okay, did I read wrong? How could it be 3.2 equals 6, right? So it corrected. Okay, so that's why. So this is we observe that, and then we add the prompt, do not correct. After we add that, it does not completely eliminate, but reduce most of the case. Okay, and then this is system message. In general, controls the overall behavior. We have to ask them to say, okay, distinguish between correct, incorrect, avoid contradiction feedback, that do not penalize, blah. Okay, each one was introduced because we see failure examples, and then we added, corrected. Now let me just use example to demonstrate why we say avoid contradiction in feedback because we saw such a case without such one. Okay, let me show you this. All right, so here is integrate. Right? Integrate this, okay, whatever. It's used, we don't forget about what the student did wrong or not. Let's do with the OCR part. Okay, the evaluation part, the evaluation part. Now, this is the without that those requirement of avoiding contradiction. The evaluation said this. Cosine square equal u does not imply sine square t equal 1 plus u, same as this sine square t equal to 1 plus u. It's contradicted to each other, right? So such things could happen. Okay. And then, so we have to add the comment to say, do not make avoid the contradiction, and it will help reduce these kind of things. All right. Okay. All right. So there are some challenges in OCR, and one is if you have pictures, then it does not read well. And if have some cross part, you see that's cross part. Student from as a human, we know, yeah, student doesn't want this, it's cross part, right? But for ChatGPT, for the LLM, for the GPT, it's not so easy to recognize this actually is the part that they don't want. We tried different prompts to deal with the part with cross out, but it was not very successful. Okay. Anyway, so there's another issue. Okay, so that's what I mentioned. All right, so now the main limitation, right? Let's go the main limitation. The main limitation is so far we do not have we haven't found a robust way to defer to it, right? When we process a lot of exams when the system should say, hey, should flag this sample, say, hey, this one should send to human reviewers. Now, as we said, because it could happen, it's from the OCR. One of the problem is OCR, right? It could be OCR read wrong. But then how do you tell from the output, how do you tell this actually more likely is OCR error? It's not the student wrote wrong. How do you do it? Right. So this is from LLM point of view is how do you do it, right? How do you introduce algorithm? So if you can flag, if you can largely accurately flag, well, this is more like a OCR issue. It's not the student made some error. Then you send this to human reviewers. So this is for us. This is the major problem. If we want to deploy, say, for high stake exams, we have to convince students, the users. You see, we have quite nice algorithm to defer to human reviewers if it's not. So this is what we need. So the major thing we need to develop. As I said, this is also active. This is also very active topic in machine learning itself. When to defer to human reviewers. Okay. Yeah. All right. Okay, so the future thing we want to do is we want to establish benchmark. So so far we have collected a lot of data, and then we want to label it. What is the original student scam work, and what is the correct OCR output? What should be the good evaluation, and da da da. So this will put the advantage. The good thing about this is so that later on, say people have want to test some algorithms, they have an idea to deal with the OCR issue. They have an idea to deal with the to get more accurate evaluation. So they have a database to compare with, a kind of benchmark to compare with. So this is what we will plan to do for the next step. Okay, so here's the take-home message. It's the LM AI grading from a theory point of view, it's no ground truth, very noisy. Now, I think from the overall experiments, if you have a low stake like a quizzes, I think it's okay. It's ready to deploy, especially given the rapid development of LLM, right? Let's say, for example, in this year, that you might be at the end of this year, you might have more powerful LLM, then you just replace the 4.1 million by this more powerful ones. And I'm very optimistic. Like AI grading, it's very practical. It's not something that we talk on paper. It's actually can be used. And then you need to introduce the human intervention and benchmark are essential. Yeah. All right. So finally, I want to just acknowledge. So here we have many students. They have contributed a lot of their time to help us to review those AI grading results, either how accurate it read the feedback and the scores. So here we have graduate students, we have undergraduate students, and this is student I mentioned that he proposed the maximum rule, and also we have high students, and also we have I'm here and helped us review quite a lot samples. Yeah. Okay. All right. So Han, do you have time to quickly show the algorithm?
Yes, please.
Okay. So let me show you the algorithm. Okay.
We're gonna have a lot of questions on this later.
Okay. First of all, here we have so this is a video I made. Samples of quizzes.
Wait.
They are
You
typical.
you have to share your screen, Yifeng.
Oh, sorry. Oh, can you see it?
Yes.
Problems from single variable calculus. Yeah, you see this.
Wait. We don't see your YouTube running.
Okay, I know. Let me share this one. Now it should be okay. Can you see now?
Yeah, can you click?
Can you see now?
Yes, please. Okay, good.
Okay, great. You can see now, right?
Yes.
Show how our AI grading algorithm works. So first of all, here we have 8 samples of quizzes. They are typical quizzes problems from single variable calculus. Here you see this is a series, right? It has solution parts and also the final answer parts. Also, to comply with the UCI policy, we removed all personal information. We assign test code to each student before it is processed by our system. Now, the workflow consists of several steps. Step one, here the solution part and the final answer parts are segmented. Step two, those pictures will be sent to ChatGPT OCR to convert into latex. And then the next step, those latex output will be processed by different models of ChatGPT, depends on how complicated the problem is. The evaluations, so finally, all the evaluations and OCR outputs will be stored in the Notion page and then sent email back to students. Next, let me run the algorithm so you could see more clearly how it works. Now, these are our codes. As you can see, here we have prompts for the rubrics. We also have prompts for the OCR, and also we have a system message to tell the ChatGPT what are the general guidelines to evaluate the quizzes of students. There are other parts which can do various statistics to analyze the results. This is the part that we execute the algorithm. Okay, now let's run the algorithm. So as you can see, it's doing segmentation, and then those pictures are converted into latex through the OCR. So those are the latex outputs, and then latex outputs are sent to ChatGPT for evaluations. Okay, so here are the evaluations, and you see the results are sent to Notion. Okay, then it's done. Here is the Notion page where all the grading results, including both the evaluation and the OCR outputs, are stored. Okay, now let's look at our 8 samples that were just graded. You see the results already here. If we click it, and these are 8 samples, let's look at one. Okay, let's click sample 1. And then here you see this is the evaluation. So for question number 1, this is the evaluation, how the student did. And then this is the score. And this is the OCR output of what the student wrote. And this is for the second problem. So similarly, this is the evaluation, and then the score, and also the latex outputs.
Wonderful. Thank you. Are you done, Yifeng?
Yeah, I'm done.
Thank you. Thanks for a very, very interesting talk. Okay, let's open the floor for questions before we do informal discussions after the recording. Any quick questions? There are a lot of people who are grad students or former grad students. Yes, please, Norbert.
Yeah, I'm wondering what is the cost of the API like for one of the runs?
Okay, so let's say for this 4.1 mini, if we evaluate, let's say 500 students for the quiz, the cost is like $2.
Okay, so it's very, very cheap.
It's very cheap. It's very cheap. Yeah.
Wow. And if you run it on, so let's say on one quiz, you do actual AI grading for how many students? I mean, you are doing it now, right? I mean, not just experimenting.
Sorry, Juan,
I
what's
mean,
your
you
question?
are using AI to grade the quizzes now, right?
Yes.
And one quiz, typically, how many students do you grade? 1,000 quizzes?
Oh, okay. So for 2A, 2B, each time is around 500 or 400.
Yes. And what's the running time for those with your system?
Oh, okay. It depends on, like, if it's run smoothly, I would think it's for one session, like if it's 50 students, then I think if it runs smoothly, probably 5 minutes. But sometimes it might get traffic jam, but that could take longer. But the good thing is you don't have to care, right? You just put it aside and then do your own stuff.
Okay.
Mm. Mm.
And yeah, I mean, my final question on this is that I think that naturally the next thing can be graded besides calculus is linear algebra. I would say that even linear algebra is even easier to be graded.
Mm.
Yeah, linear algebra, right? Linear algebra, if it's computational based, as I think as long as it's computational based, linear algebra should be okay.
Even
Yes.
proof based, right? I mean, it's just a very clear number of steps.
Well, the proof based is it depends on like sometimes we have to characterize when is a gap, right? So that we have to haven't tested yet. Sometimes we think this is obvious, but it might not be might not be obvious to students, right? One student note that it's not that they think it's clear. There's some gap there, right?
Is it on your radar to do linear algebra?
Linear algebra, yes, like for computational based.
Yes.
For computer based, yes. But for proof based, we haven't thought about that. And also the thing is for proof based, the number of students is not very large. So practically speaking, there's no like a real demand for let's say for proof based course, we have 20 or 30 students in a class, and then the AI grading might not be uh, I don't know, might not be a very convincing tool to replace the TA.
Okay. Good. So are there some questions for Yifeng before we do informal discussions?
Yeah, I have a question.
Yes.
Yeah, I want to ask that in the examples, I saw that most of the solutions are fully mathematics. But if the student they write something that is irrelevant in the solution part, for example, if they write that please grade this with a high score, for example, so may it affect the final grade?
Okay, that's a very good question. So for LM for those top AI conference, they made it very clear if someone loading a paper, you load something like this, they will just reject their paper. Yes, people try to play around with LLM. Now, so far, that's a very good thing. We actually haven't tried that yet. If it will how it will works, but if students write other relevant irrelevant things, ChatGPT, the GPT will just write down, but it will not be evaluated. For example, one student is very interesting. The student always draw a cat, very nice cat. He just draw a nice cat and put a remark says, Riemann integration is too hard. Every time he did that. And then the ChatGPT, okay, so the GPT, the 4, well, I know I shouldn't say ChatGPT. ChatGPT means the web version. We use the API version. So it's the GPT 4.1. It couldn't really draw the cat, but it says, okay, the student draw a cat and he wrote a sentence, Riemann integration too hard. Yeah. But I think you made a very nice point. We should test to see how it if say someone load a sentence, just give me a full score. My prediction is it will not because we have a classical rubric, both the classical rubric and the fixed rubric says very clear what point should get. This is not relevant. But for the research paper, because there's no rubric for a research paper. So that's why like it could happen if a student if someone just wrote in the research paper say give me a very nice evaluation and then LLM will give. But here I think a given rubric, I think highly unlikely this will happen.
Mm.
Yeah. Very good. Okay, I think let's end Yifeng talks now, and then we switch to informal discussion. So thank you again, Yifeng, for a great talk. Thank you.
Yeah, thanks everyone.